everyone. Welcome to iTalk10 Immunology series for today. And today we will discuss cancer immunology. And with me is the co-host Joshua. Joshua, say hi.
Hi, Steve, and hi, everyone. Thank you for today's discussion.
Cool. So we'll move deep into the discussion and unravel why cancer is quite a stubborn thing up to this century. And so, Joshua, I'm sure you've understood the details of cancer and cancer pathophysiology, the genetic mechanism, and you also understand the basic role of immunology in clearing out any foreign material within the body. So, why do you think cancer is still challenging to through immunology? Why can't immunology still address cancer today?
Well, I think the question to immunology as a cure to cancer immunotherapy may go back to tracing it in his history or in 1891. It's had quite a great deal of long journey. But then there wasn't much to appreciate up until 2018 when James Allison received his Nobel Prize for having elucidated properly potential means of coming up with immunotherapeutic approaches to cancer. But then even that, he emphasized that immunotherapy is just one of the legs of the stool in cancer treatment. So it doesn't mean that it will be the main thing, but it should only complement surgeries, chemotherapy, and radiotherapy. So it becomes the fourth arm in fighting cancers. But then, even as it is, I think modern understanding of cancer immunotherapy is still young and needs to be researched on majorly. But based on my understanding, I do not know what you think about this, but what is being witnessed currently is the inability to predict the efficiency of the available therapeutic approaches. So there's still a great deal of coming up with personalized approaches, because it has been appreciated that various patients respond differently to the chemotherapeutic options that are available, especially in light of the chimeric antigen T receptor, the checkpoint inhibitors, and oncolytic viruses. So responses varies, and I think it has not been predicted well. So that is why it's still a baby in its walk. Again, they still need to identify new and biomarkers that are more immunogenic, because what is available right now is in light of immunology, there's still no proper library of molecules that T and B cells would consider to be antigens. And there have also been observed mechanisms of resistance development, especially with the CAR T cells and oncolytic viruses and the checkpoint immune inhibitors. Because as you will appreciate, the pathophysiology of cancer is basically genetics, and it's gene modification on the move. Okay, so they mutate a lot, and then I do not think there's a current proper clinical study designed to optimize the efficiency. And then finally, there's the cost, which I think is a bit prohibitive at the moment.
Oh, okay.
Yeah.
So, basically, you've espoused on the challenges that immunotherapy have in cancer today. But looking at this subject more intricately,
Yes.
you see, in every circumstance of the body, there is always the immune system, leave alone what is being done in the research. There's
Yes.
always the immune system at hand, always
Yeah.
responding to what it considers foreign.
Yeah.
Much as we may appreciate, cancer is foreign to some extent.
Yeah.
It's not something that the body evolved with during birth, even during growth. It's something that is coming up. As much much as it's using the body cells and using the body material to build up, it's a
Yeah.
novel thing. And each
Mm.
time we have a cancer build-up, we have cancer antigens being produced that the
Yeah.
immune cells can really consider as foreign, and the cytotoxic
Mm.
T cells can now come and eat up the cancers.
Yeah.
But you still find the cancers that we can consider immunologic and in immunologic context,
Yeah.
they still overwhelm what our immune system can do. Why do you think the immune system itself, let alone therapy, let alone
Yeah.
research, why do you think
Yeah.
the immune system in itself cannot really attack cancer? Because it attacks any pathogen introduced. It attacks COVID, it attacks SARS-CoV-2.
Yeah. Yeah.
It rapidly eradicated hepatitis B virus when it entered. Why is cancer so strange to it?
Well, I think you've now put it well, because now we are looking at the natural reasons as to why cancer patients are unable to eliminate them without
Mm.
any kind of assistance. Why
Yes.
is the system in itself failing?
Mm.
But then again, it goes on to understanding what kind of mutations cancer cells undergo.
Mm-hmm.
And if you'll agree with me, then it's known that when cancer cells mutate, first of
Yes.
all, they tend to induce a state of immunosenescence.
Mm. Mm-hmm.
And if
What would you mean by that?
there's a tendency to fatigue,
Yes.
to fatigue the immune system,
Mm.
and whenever an antigen is constantly available, the clones
Mm.
that were selected to mop them up will always be dividing. And in the process, there's the observation of a telomere becoming shorter and shorter and shorter,
Mm. Okay.
so that at the end of it, these cells are more mortal than their
Mm-hmm.
ancestors were. So
Oh.
again, that is now what we refer to as
Mm. Mm.
immunosenescence.
Oh, awesome. Awesome.
Again, we have some of these cancers, once they have developed a kind of antigen that the immune system will identify,
Mm-hmm.
and then that system now becomes of interest to T or B lymphocytes,
Mm.
their genes are on the move. They change that again,
Yeah.
and
Yeah.
it's
Yeah. Yeah. Yeah.
it's a
Yes.
whole
Yes.
set of antigens. So it's some kind of an immunoevasive strategy.
Yes. 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 So it's like a camouflage in some kind of a way.
Yes,
I mean,
exactly. So you find that
once you've realized this is your head, now you bring another head now.
you bring another head and all that, and then there's also certain kind of cancers utilizing the checkpoint inhibitors. For example, you
Mm.
have in the formation of the immunological synapse, they
Mm-hmm. Mm-hmm.
will strongly activate the CTLA4 ligands and all that, so that
Yes.
instead of cells becoming active, they are
Mm-hmm.
energized or more tolerant to certain cancer
Yeah.
cells.
Yes.
So
Yes.
I think that is the mechanism that happens in the natural sense, so that without any external intervention, still the immune
Mm.
system in itself cannot eradicate cancer, especially for aged patients whose systems are now becoming weak and of
Mm-hmm.
aged. Yes.
Yes, and in the last process you've just defined there, it's one of my favorite topics in cancer immunology. I mean,
Ah.
when cancer cells confuse the CTLA, and now it causes the T cells to be exhausted now.
Uh-huh.
Once we have exhausted T cells, now they look
Yes.
like dogs without, is it
Without
called the
teeth.
dog without teeth?
The toothless bulldogs.
Yes, yes, yes. So they are just there, but then
Yeah.
looking at cancer without doing anything.
Mm.
And those are one of the work that checkpoint inhibitors kind of really try to revitalize. And in essence,
Yeah.
there's also uh, efforts to try and work with the metabolic processes that really can wake up the exhausted T cells, because research really indicates that if they're woken up,
Yeah.
then they can't really do the function that they were supposed to do. And it's
Yeah.
really
But
a nice process. So.
yeah, but then I'm also looking at it from a clinical standpoint.
Mm-hmm.
when cancer cells are trying to suppress or activate the checkpoint inhibitors, and the clinician tries to revitalize those systems, there have been a number of publications where patients respond adversely and at some point needs to be admitted and such
Okay.
kind of treatments withdrawn, because imagine a situation where your immune system is hyper, okay,
Mm.
because certain checkpoint mechanisms are now taken away just so that it can attack
Yes, 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 yes.
certain hazardous bunch of tissues in your system.
So it
So
depicts.
again, yes. So in fact, I think there's a publication that indicated that more patients have reacted or responded negatively to the cancer immunotherapeutic attempts
Mm.
than they have positively.
Oh,
Yeah.
wow, wow, wow. So it's kind of, it brings a sense of we now become. You see, mm, during embryology,
Yeah.
as you can recall, uh, the body really tries to eliminate those cells that can be aggressive against the body. And I think that is
Yeah.
one of the fundamental roles of the checkpoint inhibitors, so that they can really control to what extent the immune system reacts against
Yes.
pathogens. And therefore,
Yes.
once
Yes.
they're eliminated, then now
Mm.
there's no control. There's no control. And now things
Yeah.
just react the way they want.
Yeah. The very one. There's no limits.
Yeah, there is no limit. Have you ever heard of a situation where a cancer cell confuse the immune cells? I mean, this is what sometimes they do. Uh, Once cancer cells have realized that these immune cells can be dangerous,
Yeah.
they welcome the immune cells within their cells. That
Yes.
is, cancer cells seem to absorb the immune cells. And now the
Yeah.
immune cells now, while residing in cancer, now feel
Mm.
at home. They feel at home. And they now fail to even do whatever they were supposed to do.
It's like they're invited for a cup of tea by the enemy
Yes,
and then they
yes.
get full.
And they never fail to leave. I think.
I, I think there's a kind of anarchism that happens.
Mm-hmm.
Yeah, so that instead of them being made more active,
Mm-hmm.
probably interleukin 10 could be mentioned somewhere that these cells are energized. So there's a clonal energy. Lure them into a trap and then defang them.
Yeah, that is really that's really awkward for, and I would call it archaic for cancer cells anyway. But in such cases, you will find that's where you will find people have wounds that do not heal,
Uh-huh.
because
Uh-huh.
when,
Yes.
once cancer begins to invite those immune cells, now we have wounds that
Yeah.
really cannot really heal.
Because I also think there's a sense of production of more Tregs,
Mm, mm,
which
mm,
has a
mm.
domino effect on the overall population of T cells that are actually active.
Then it then seems that moving forward, we must
Yeah.
approach cancer in a personalized therapy approach than
Yeah.
a universal approach,
Yeah.
because not all cancers behave the same.
Mm.
Uh, for example, cancer that invites immune cells within themselves do
Mm.
not behave same as cancers that make T cells or cytotoxic T cells exhausted.
Mm.
So there must be a personalized approach to these things so that you can at least have the better benefit of it.
Yeah. No two mutations are identical.
Yeah, sure. And
Yeah.
so, moving forward, where do you think we should now intensify our research on cancer? Assuming somebody were to give some funding somewhere and tell you this can be a $1 billion project, where can we intensify?
Well, that's really a tricky question, given this is a modern topic, fairly recent, considering the success and failure rates of the trials that have been put in place. But then, just as we have mentioned, there's need to personalize how cancer patients are being handled, especially in light of immunotherapy.
Yes.
And
Yes.
better clinical designs need to be put in place. And I think the most important thing is to identify more immunogenic markers because based on a number of publications I have seen, I think the main reason as to why some of these uh, cancer cells are evasive or slippery to the immune system is that the antigens that were identified was not as immunogenic. So they weakly
Okay.
activate clones. So if more research could be given so that even if you're dealing with, let's say, a sarcoma, for example, you want to identify a strong antigen that is standard across all. Because again, millions and millions of people have cancer as a disease, and I think personalizing this would be a little bit challenging given the health systems that we have, especially in Kenya and in Africa as a whole. Yeah, so a standard antigen could probably work, and if this could be made into a vaccine, for example,
Okay. Okay. Okay.
something like that.
Okay.
I don't know what you think.
Uh, Finding a common antigen to me can sometimes be really confusing,
Mm.
especially when I look at it in the sense of acute myeloid leukemia and chronic myeloid leukemia.
Yeah,
Uh, so these leukemias, while they are divergent to some extent, there's
yeah,
a place that they now converge in the sense that you cannot phenotypically and genotypically tell whether this is acute myeloid leukemia or chronic myeloid leukemia for one reason,
mm.
because
Mm.
sometimes they share certain genetical mutational profiles within them. You will
Yeah,
find you will find a genetic lesion that is common for both CML and common for AML. So
yeah.
if you find a lesion that is common, then I
Mm.
think diagnosing cancer will be confusing in the sense, uh,
But
but
what do
perhaps
you think?
targeting it,
If yeah,
I think perhaps targeting the lesion will be beneficial. However, it will bring confusion in terms of diagnosing cancer. That is why personally I support identifying unique markers than unified markers, just to
unified.
improve what kind of decisions the clinical clarity in decision making.
Mm. So again, it comes to personalization because it means for every patient uh, presenting with myeloid leukemia, be it acute or chronic, then there's need to have a genetic profile of those tumors.
Yes, 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 yes. Uh,
Okay.
I still think uh, the one you mentioned at the beginning of the show, that is
Yeah.
checkpoint inhibitors. I
Yeah.
think it's something we still need to fund heavily,
Yeah. Mm.
because the idea that T cells become exhausted is common in most cancer. So if we heavily
Mm.
investigate why do these people behave aggressively against these checkpoint inhibitors, and why don't others
Mm.
behave? Why can't checkpoint
Mm.
inhibitors at the end of the day successfully help in eradicating the cancer? The other
Yeah.
thing we might, for example, intensively fund is
Mm.
the use of chimeric T cells,
Yeah. The
the one you call the CAR
country.
T cells.
Yeah.
Yes, I think they can also be quite revolutionary in terms of shaping how cancer is managed. I think those are my two best that maybe I can encourage heavy funding of them.
Mm. Mm. Uh, in line of the fact that there are mutations against the chimeric T cells, again, that challenge would still exist, but probably targeting antigens antigens whose mutations
Mm.
would be detrimental to the cancer cell would be a good thing.
Yeah, yeah,
So that
yeah.
you have a T cell against a specific antigen on the tumor, and if that antigen ever mutates,
Mm.
or the genes coding for that antigen ever mutates, then that cell is no longer integral.
Oh, okay, then we still have a long way to go anyway.
Yes.
Still have a long way to go. And
Yeah.
as you always say, we cannot comfort. What do you say?
Compartmentalize. Yeah, like one thing, like focusing on checkpoint inhibitors alone, which by the way I think these things are complementary. So in the event that a bunch of tumor cells are trying to lure T cells into a trap and make them weak, then you have the checkpoint inhibitors also being told, hey guys, slow down. So it's complementary.
Yeah, sure. So let's rapidly fire the next agenda that you
Sure.
mentioned something like senescence uh, earlier on.
Yeah.
So you think immune cells age?
Yes, I do. I don't know about you, but in fact, I think immune cells are the cells that age the most in all somatic cells of our system
Why would you think so?
because they're the ones that divide the most. Look at T cells, look at B cells, look at dendritic cells, for example, in the face of an active infection. Okay?
Mm.
And many a times, some of these divisions are happening peripherally so
Mm.
that there is no any support to the telomere.
Okay,
So
okay.
the faster the division or the faster the clonal expansion, the faster the aging process, which is a genetic mechanism.
Oh. And so you think this aging of immune cells can it affect the progression of cancer?
Well, I think in a way it does, in a way it doesn't affect, because if an individual has an active thymus,
Mm.
the new clones will always be produced.
Mm.
And if you already have memory T cells in reserve, they can always be recruited.
Oh.
But there is a disadvantage in this war because
Mm. Mm.
cancer cells are considered to be almost always immortal.
Yes.
For some reason, they, they divide indefinitely without
Yes.
dying. So the population
Mm.
will constantly be increasing, and if that is left unchecked, they grow even faster.
Sure.
That is an
Sure.
advantage that immune cells don't have. So while there'll be a constant need to replenish the troops,
Mm.
cancer cells are increasing in their number, so it becomes a disadvantage.
So ideally it's true that immune cells really age. I will not be sure whether they age rapidly compared to other cells. Maybe cells of the cheek really. Okay, but I will not be sure whether they. But what I'm sure is
Yeah,
that the aging immune cell,
yeah,
especially the aging T cell, is
yeah,
really a liability to cancer immunology in the sense that you see, like you
yeah,
mentioned, when these cells age, the telomere shortens, and therefore what we have is that it will affect uh, the composition of the T cell receptors
yeah,
in the sense that instead of having 50,000 unique T cell receptors, then we only have 20 or 10. So the repertoire of the T cell receptor will really be affected, and in fact, it will be deficient. Now, if we have a restricted T cell repertoire,
yeah,
the negative implication here is how well would they catch, quote unquote, the cancer antigen. And so the aging T cell, to me, I consider it as a complete liability to attacking cancer or even identifying cancer immune cells. That is why adoptive T cell therapy
T cell transfer.
really should
Yeah.
really come in, because those that age within us, uh,
Mm.
those are toothless dogs now.
Yeah. Now, I don't know. Are you able to link clonal exhaustion to aging T cells in the face of an active tumor growth?
Uh, That would be really a challenging.
Because
Uh,
it's actually a strategy in certain active infections. I'm not sure, but I think HIV is implicated in this.
okay.
That there's a deliberate mechanism where these pathogens shed antigen,
Hmm.
and clones that have been selected to identify these antigens expand
Hmm.
at a very rapid rate.
Then they
And in
become
the process
tired.
of expanding, their telomeres become short with subsequent divisions. So then they
Yes.
age very fast, so that
Mm,
that
mm.
clone is exhausted and eventually depleted.
Oh, oh.
And
Okay. I think that is quite new to me, especially linking clonal exhaustion to an aging cell.
yeah,
It's fairly new to
clonal,
me.
yeah. So I'm just thinking in the face of an active cancer, because cancers with the antigens will stimulate the production of adaptive cells of the immune system to act against these antigens.
Yeah.
But because their population is abundant, there's an abundance of antigen.
Hmm.
Ultimately, this affects the clone that acts that antigen because they are more active, and over time they become exhausted
Yeah, and lose their
and they
function.
lose their functionality. So I think that is also one way. So I also want to agree with you that adoptive T cell transfer would
Mm.
really come in handy to boost the exhausted clone.
Yes, yes. Uh, as we come close to the talk, there is an awesome publication. I don't know whether you come across it, where uh, T cells, their aging can be shortened.
Yeah.
What do you think about the paper?
Well, this is antigen presenting cells playing God, imparting immortality to cells. Well,
That,
it's actually an interesting paper because it's like
hmm.
they have a life-giving capability that is their
Yeah,
telomere, and they're transferring it to a T cell.
they seem to be sacrificing a lot.
Yeah, they're sacrificing. Now, one thing that I find to be interesting is that this this mechanism is shown to be occurring at the central naive and central memory cells.
Mm-hmm.
So I understand naive cells are those that are mature but have not interacted with the intended antigens.
Antigen, yes.
So in the process of interacting with an APC,
Mm.
then they get that transfer of telomere.
Telomeres. Now, it's assumed that maybe they can live longer.
Yes.
Then,
Now,
okay.
then, if this mechanism happens naturally, then why do we
Yes.
have aging
That's
T cells?
another fascinating question, anyway.
But then it
It's,
presents an interesting opportunity. It
yes,
could be that the mechanism is happening at a low grade level somewhere.
perhaps, perhaps.
If it could be amplified, then
Hmm.
probably the aging process could be arrested.
But now, I have a fundamental question here.
Uh-huh.
Now, here we have antigen-presenting cells
Yes.
transferring uh, telomeres to naive T cells.
Yes.
Now, at the point of transfer,
Yes.
is it that these cells are exchanging antigenic proteins, or what do you think they're exchanging at that time? Because
Well, I.
APCs for APCs to interact with the T cells, there must
Mm,
be a visitor involved.
mm. Now, what they're donating, according to this publication, is the telomere.
Yes, that is what they're donating.
Yeah, so these are base pairs.
Yes, but now my fundamental question is:
Yes.
at the time of donation, for You see, APCs can't just wake up from their residential areas and move to
Mm.
where T cells are, just like that.
Mm.
They must be triggered. Once they are
Mm.
triggered by proteins, that
Mm.
is when they grow their legs and now move to the T cells.
Mm.
Uh, uh, to me, I consider that is maybe, perhaps that is because that is where now they meet the naive T cells.
Yeah, the naive T cells. So I think
At, the,
it yes.
at that point, they are, I view it as exchanging the antigens at that point. Then besides exchanging antigens,
Yes.
then they
Yeah.
also donate the telomeres. Now, if my view is true, then
Mm.
that cannot really help aging. It cannot really help an aging T cell.
Okay, this is how I understand it, and maybe we should get the owner of the paper explaining this more, because we are hypothesizing a lot. But I get that the process seems to be occurring during antigen presentation
Yes,
and priming of T cells. So it
yes.
means that the antigen presenting cell is already activated by virtue of having an antigen in its cytoplasm somewhere.
True, 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 true.
And then as it moves to the T cell area in the lymph node, it
Hmm.
interacts with the T cell. It could be a TH or a TC. So that in the process of activating this T cell,
Yes,
it also transfers
the telomeres.
the telomere. Yes.
Now, when they are, it then means that when there are no antigens,
Mm.
then you cannot extend the telomeres of those 90 cells.
There's none.
Yes, then it means that maybe this process, okay, perhaps I will email the author to have a chat with us.
Yes, yes.
Uh, but perhaps it might help to some extent in helping aging T cells, especially if engineered, to
Yes.
help in cancer immunotherapy. Again, if engineered.
So then, there could be just APCs that are designated
Mm-hmm.
to be donors for the telomere.
That's also another fundamental question that maybe the author can really clarify so well. And
Yes.
yeah, I think I'll need to call the author to the show so that at least
Yeah,
uh,
we have them dissect this
yeah,
concept. It's an
she,
interesting one.
true, 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 true. And
Mm.
with that discussion, I think we have marked the end of the show. And
Okay.
perhaps you might be having something as a closing remark based on the topic.
Well, not much, but I think we still have a long way to go. And much as immunotherapy is having its limitations,
Yes.
it is also presenting us with opportunities and promising leads to the fourth pillar of cancer therapy.
Mm, mm,
Yeah.
mm. To me, uh, we are still new in the world of cancer immunotherapy, cancer immunology,
Yeah.
and ideally we need to put more funding into this.
Sure.
Otherwise, thank you for listening and enjoy the show.
All right. Thanks, Steve, and thanks everyone. See you next time.